In these images, you can see cutting and typical lights in the sky. You might have seen it before, and most of you might know about it. Actually, these lights are auroras or aurorae. They are also commonly known as northern lights or southern lights. Northern lights are also called the aurora borealis, while southern lights are also called as aurora australis. Northern lights or aurora borealis are one general equivalent of these terms. If you are curious to know about these lights, then it may be an interesting video for you. An aurora is a light that is displayed in our sky. Predominantly is seen in the major latitudes of Arctic and Antarctic. Let me clarify use the difference between latitude and altitude, because these are the terms the radiation is different in the meter and weight reduced. Latitude, altitude weight, learn handling which you love. Latitude is the distance measured in degree, minutes, and seconds, north and south on the equator, while altitude is the distance measured in feet or meter. About the mean sea level or in rare instances, you know the mean sea level. Auroras display tiny patterns on brilliant planets that appear as curtains, rays, spirals, or diamond twinkles covering the entire sky. Interesting. In short, auroras on the desert are the magnitude square caused by solar winds. Most of the planets, natural satellites, brown dwarfs, and even comets also post auroras, as in the image you can see, all around the planet Jupiter. On Earth, auroras are mostly seen at night against our dark sky. A region that currently displays an aurora is known as auroral oval. The submarine displays like the solar wind scored over the night side of the Earth. In northern latitudes, the effect is known as aurora borealis or northern lights, while the southern counterpart to the aurora australis or southern lights has features almost identically running through the aurora borealis and changes simultaneously with the change in the northern aurora zone. The southern lights are visible from high southern latitudes in Antarctica, the southern pole, South Africa, Australasia, and in exceptional circumstances as far north as Greenland, while the northern lights are visible from the rigid Antarctic like Alaska, Canada, Russia, Scotland, Greenland, Ireland, and Scandinavia, and as far south as Mediterranean and the southern parts of the US. Auroras seen within the aurora oval may be directly overhead, confirm that they illuminate the polar horizon and with greenish slope was sometimes as uncanny as if the sun is visible from an unusual location. Auroras also occur onward of the follower zone as if you stretches were us, which can be some visual. Auroras are easily seen below the auroral zone, where the geomagnetic storm temporarily enlarges the auroral oval. Early work on the imaging of auroras was done in 1949 by the University of Saskatchewan by using HCR-70 radar. The altitudes where aurora emission occurred were revealed by Carl Stomer and his colleagues, who used cameras to triangulate more than 12,000 auroras. Actually, Carl Stomer was a Norwegian mathematician and astrophysicist. They discovered that most of the lights occur between 90 and 150 kilometers over the ground, while extending at time to 1,000 kilometers. According to the short plot, there are five main points of auroras that can be seen on ground from east to northwest. Number 1, mine globe. A mine globe near the horizon. These stands close to the limit of mobility, but can be distinguished from moonlight globes as the stars then seen from these lights. Number 2, patches of surfaces. Patches of surfaces that looks like cloud. Number 3, arcs. Arcs go across the sky. Number 4, rays. Rays are light and dark strips across the arc, reaching upward by various amounts. Number 5, pronouns. Photographs cover much of the sky and diverge from one point of it. Arcs can fragment or break up in separate as signs that they change. Octagraded features that reveal the whole sky. These are also known as discrete auroras, which are at time bright enough to read a newspaper by at night. Interesting. The videos of the arcs, rays, curtains, and photographs are determined by the shape of the luminous part on the atmosphere and the viewer's position.
Auroral lights made of red color, green color, blue color, ultraviolet, infrared, and yellow and pink color, which is a mixture of red and green or blue. Some shades of red as well as orange and gold may also be seen on rare occasions Yellow-green is moderately common. At shorter time scales, auroras can change their intensity and appearance, sometimes as low as difficult to notice, but other times they're friendly down to the sub-second cap. The phenomena of pulsating auroras are known as intensity variation over a short time scale, typically with time of 2 to 20 seconds. Auroras and associated currents produce strong radio emissions of around 150 kilohertz. That is known as auroral kilometric radiation. That was discovered in 1972. X-ray emissions from particles associated with auroras have also been detected. Noise of aurora is just like cracking once, begins about 70 meters above the ground. A full understanding of the physical process which led to the formation of different types of auroras is still incomplete. But the basic cause involves the interaction of solar winds with Earth's magnetosphere. The varying intensity of solar winds produces effects of different magnitudes, but include one or more of the physical scenarios. You can read these physical scenarios by watching the video. I'm not paying too much attention on this topic because the details of these phenomena are not fully understood. But however, it's clear that the prime source of auroral particles are the solar winds creating the magnetosphere. The reservoir containing the radiation zone and temporarily magnetically trapped particles confined by the geomagnetic field, combined with particle acceleration process. These were few information about auroras or polar lights. Hope you got to know something interesting.